Let's move on to the got it. The graph shows the projected altitude f of x of a plane scheduled to depart at noon. Same problem. Suppose, though, that the flight leaves, look at this, 30 minutes early. What function represents this transformation? If f of x is the original, then we need to figure out what 30 minutes early would look like. Well, since it would be shifting to the left now, and it did give you a little trick, the 30 minutes, you need to change that to 0.5 of an hour, okay? It's going to shift to the left because it's leaving earlier. You would have to do x plus 0.5, okay? So it's leaving early, you have to add 0.5. If it's leaving late, you have to subtract 0.5. Now, I just dropped my calculator case. If you want to see the graph of it, if this is the original, you would just back everything off by a half. So instead of being, you just kind of go to your points and you would take off a half. It'd be kind of hard to show you, but let's see, it would be something here. You would just go back to a half on all of them. Kind of goofy. You just take all your main points and go back a half. So you can see that what I'm doing is I'm shifting the picture. I'm shifting the picture back by a half an hour. Okay? It's like a half a block. And pretty much all these like points go back half a block. Something like that. Okay, so you can see the time. And if this isn't making sense to you, you can kind of see, ready? This is what's happening. The plane takes off, it goes high again, it levels out, and then it comes down to land. That's what's going on. As time continues on, the plane goes up and the plane goes down. So D is our answer. Now the next thing we need to look at is what's called reflection. Reflection flips, can you circle that word? Reflection flips the graph of a function across a line such as the x or the y axis. Each point on the graph of the reflected function is the same distance from it what there was before. Now, let's talk about some very important pieces of information when we do this, okay? When you reflect in the y-axis, I want you to write that down. When you reflect in the y-axis, now remember that's the vertical axis. When you reflect in the y-axis, the x values change and the y's stay the same. When you reflect in the x-axis, that's this line, the x values stay the same, the y values change. For a function f of x, reflection of the y-axis is when x is different, reflection of the x-axis is when the whole, remember how that's just a fancy way of writing y, is when the whole f of x is negative. Let's take a look. If this graph right here is your original graph, this graph right here, ready, here it is, this graph has been reflected around the x-axis. Here's your x-axis. See how it's been flipped upside down? That means that the y values change. And that's because it's been flipped upside down. That changes these values to negative values. Look over here. If you flip it around the y-axis, in other words, if you take this picture and you flip it over here, I'll do that one more time. If you take this picture and you flip it over here, that changes the x values. Okay? So here you go. Say it one more time. Reflect around the y-axis, change the x's. Reflect around the x-axis, change the y's. Let's test it out, see how well you do. Let g of x, which is just another fancy way of writing y, be the reflection of f of x equals 3x plus 3 in the y-axis. Okay, let's circle that and let's write something we know. If you flip it in the y-axis, that means you change, ready? Y-axis, change the x values. What is the function rule for g of x? Alright, so I gotta change the x values. Are you ready? So, if I have, and I'm just gonna bring this down. If I have originally y equals 3x plus 3, if I want my new one to be reflected in the y-axis, I change my x values. So change x values. Ready? Here we go. My new one would be y equals 3 times negative x, and there's my change. Plus 3. So I didn't change anything else but the x values. So that's y equals negative 3x plus 3. And they wanted us to use g of x, so we'll make it pretty just for them. G of x equals negative 3x plus 3. That wasn't too hard, right? You just make your x negative. I want to graph this. This is a straight line. You should know that that's a straight line with b equals 3 and m equals negative 3 over 1. Let's graph it. Go up 3, 1, 2, 3. Go down 3 over 1, down 3 over 1. Connect. I'm going to put this one in orange because that's what it is. It's our new one. It's our special one. I'm going to write the word new beside it. Now if you want to see the old one to see how it actually did reflect, all you have to do is graph the old one. You can go up 3, and then you would go up 3 over 1. Ready? Watch this. That's the old equation. Now can you see how here's the y-axis. Can you see, let me try to move it there for you. Can you see how it's almost been folded around the y-axis? It's pretty neat how that works. Alright, let's take a look at the got it. Let h of x be the reflection of the same equation, but this time they want it in the x-axis. Alright, if we reflect it in the x-axis, that changes, what does it change? It changes the y values. Alright, we can do this. So if originally we had y equals 3x plus 3, to change the y values, our new one would be, I'm going to make my nice and big and orange here, you just change the y values. So you do negative y. That's it. You just change the y values. Equals 3x plus 3. And of course we have to resolve this for y, so we'll divide everything by negative 1. So that gives me y equals negative 3x minus 3. So let's find that on here. Oh, and they wanted us to use h of x, so I better change that to h of x equals negative 3x minus 3. There it is. Let's find it up here on this. I see that D is the answer. Now if you wanted to see it on your graphing calculator, you can see how it flips differently. The original was 3x plus 3. The new one is negative 3x minus 3. Graph them. Now look at this. If I hold the ruler here, that's the x-axis. Can you guys see how it's been folded around the x-axis? The last thing I believe we need to talk about is vertically stretch and vertically compress. Okay? The easiest thing for me to do is just to show you a quick example. Alright? If your original is f of x, who cares what it is, then to vertically stretch it, you would have to multiply by something like 2, something bigger than 1. Okay? If you were to vertically compress it, you would do something like 1/2. It's pretty much that simple. Just remember that f of x are the y values, any y value, okay? So if you have a y value, to stretch it, you multiply it by 2. To compress it, you multiply by 1/2. Let's try this in problem 4. The table below shows, represents the function f of x. All right. What are the corresponding values of g of x and possible graphs of g of x for the transformation of g of x is 3f of x? Whew, that's a lot to take in, right? All right, well, let's just take a look at this 3f of x. Since it is being multiplied by 3, all that means is that you multiply the y values by 3. That's it, guys. And it's going to be vertically stretched by a factor of 3. That's not hard, right? You guys can multiply by 3s. So here's our table, x and y. Right, because f of x is just a fancy way of writing y. So if those are our old ones, let's plot our old points so we can see what the old graph looks like. So left 5 up 2. 1, 2, 3, 2. Left 2 up 2. Left over 0 up 3, or down 3. Over 3 up 1. Over 5 down 2. Let's connect. Okay, and remember that is the old graph. Okay, that one's the old graph. Let's get the new one on there. Well, all I do is I take my y values and I multiply them by 3. Those are going to be my new y values. You ready? So I'll do 2 times 3 is 6. 2 times 3 is 6. Negative 3 times 3 is negative 9. 1 times 3 is 3. Negative 2 times 3 is negative 6. So all I do is I forget now about those old values and I plot my new values. I'll put those in orange. So left 5 up 6. Left 2 up 6. So you can see, whatever we used to go up, we now go up 3 times as high. Over 0, down 9. Over 3 up 3. And left 5 down 6. So you can see it's the exact same type of shape. You can see that it's the exact same type of shape, but that has been vertically stretched by a factor of 3.